This is the third video for section 6.1. Here we're talking about inverse cosine function. On the screen you see me graphing out the original cosine function graph with only one period. So for the same reasons, all the trig functions are not one-to-one functions. So I have to figure out I have to train my original cosine function to only like a particular piece that is really nice representing all the values for cosine. So we still like the first quadrant, so I'm highlighting my first quadrant. And then besides the first quadrant, which first quadrant covering my y value from 0 to 1, I also need the 0 to -1 piece. Luckily, when we're talking about cosine graph, is really nicely connected using both quadrant 1 and quadrant 2. So, with this with this trimmed piece, I'm going to be erasing the rest of them. I can graph the inverse graph. Okay, so I'm just labeling the point 0, 1, pi over 2, 0, pi -1. So we have 1, 0. I'm going to say this is 1, here. This is 1, 0. And then 0 pi over 2. 0 pi over 2. And then the third point is -1 pi. -1 pi. -1 pi. Okay, connecting them. And this is the inverse cosine graph. So either cosine inverse of x or arc cosine of x. From those two graphs, we can conclude that inverse cosine graph has the following definition. So we can call it either y equal to cosine inverse of x or y equal to arc cosine of x. That means x equals to cosine of y, or what cosine of y equal to x. We do have a condition for the y, where y is going to be between 0 and pi. So, the range for the inverse cosine function is going to be between 0 and pi. And then the domain for the inverse function is still going to be between -1 to 1. We do not really have any even and odd properties for the cosine inverse function. Yeah, we don't really have any even and odd properties. So I'm just going to move on to the example. So example we have is still find the value for the first one is y equal to arc cosine of 0. So by the definition, we know I can rewrite it as cosine of y equal to 0. That tells me y has a reference angle of pi over 2. Pi over 2 is actually on the y-axis, so I cannot really say is the quadrant. So I'm just going to say y, the possible the possible solutions, the possible y's are either pi over 2 or 3 pi over 2. But since we're talking about the range for the inverse function is between 0 to pi, so I cannot have 3 pi over 2. So y can only be pi over 2. The second one I have is y equals to cosine inverse of 1/2. Apply the definition that cosine of y equals to 1/2. That means y has a reference angle of pi over 3 in positive quadrant 1 and quadrant 4. Because of the range, I can only have quadrant 1 or quadrant 2, so y is going to equal to pi over 3 in quadrant 1.